So hot take, Brad, should anti-satellite technology be regulated?
The first thing is it's missiles, really.
Yeah.
Right?
A missile was shot up and blew up a satellite.
Welcome to the Deep Chat.
Yeah, which takes quite a bit of technology and technological prowess. But should they be? Yeah, if we could get everyone to cooperate, because space is already filled with debris, and it will only make it worse as new nations get that capability and want to test it, because it's already been tested by the US, India, China, and now Russia recently, right? Mm-hmm. And I think that's what we're referencing. So
why don't you let them join the league then? Everyone else has done it.
Well, exactly. That's going to be the problem. It's the same thing with nuclear weapons. When we're trying to tell countries, well, you can't have nuclear weapons, and then they point us and say, well, you have nuclear weapons, why can't we? And it doesn't quite make sense. It makes other nations feel like children.
Mm-hmm.
Oh, but you can swear mom and dad, but I can't. So why is that allowed? Do as I say, not as I do.
Well, here's a question I've always had. So I have mostly stuck to the surface of the Earth. Just that's been where I've spent most of my time. And I find it to be very, very large. And I know that circumference gets bigger the bigger you go off into space. How is this really an issue? It seems so vast up there.
Well, right. It is much larger, and some of those go out, I think, 200, 300, 400 miles. And they're even farther, maybe in I forgot the numbers, but It's vast. But they tend to collect in certain orbits, and now you have these little particles spinning at thousands of miles per hour. And what is a tiny, smaller than a golf ball sized piece of shrapnel or even plastic going to do when it hits something?
Well, momentum.
Yeah, it's going to break it. And how bad it will break it, it depends on what it's hitting. Is it hitting a solar panel on a satellite, or is it hitting tough outer shell of the ISS? Who knows?
So there is a viable circumstance where some of that debris, it has a small mass, right? So it'd have to have a very high velocity, but it can get to that, to where effectively it's a bullet floating around in space?
Right. And then, the fact is we do orbital maneuvers in spacecraft and the ISS quite often. And those orbital maneuvers are intended to move out of the way of a piece of debris that is on a collision course.
Oh.
Well, now there's a company that actually tracks space debris. It used to be a government organization that published, and it still is, there's something called Space Track, which is a government organization that feeds data into Space Track, which is publicly available. I can't remember how that relationship between spacetrack.org and the government, how that works, but it is publicly available information. It tracks every piece of debris. I believe it's bigger than a golf ball that is in space.
How do they do that? Are they hitting it with lasers, or they just know the physics?
First, how do they find the object, right? That's the first
part's
question,
more
right?
believable to me. I get that they could find it, because maybe it's a hard problem, but you do it once. But tracking it, that's the impressive part.
I can't remember what technology they use to find it. I think it's radar. We'll get an expert on. But let's say they found it.
Yeah.
Tracking it is actually easier than finding it. And it also depends upon the orbit. If it's closer to Earth, in lower Earth orbit, you can get more friction. Mm-hmm. If the object is spinning and it's flat and it's tumbling and spinning, you can get different behavior because it's going to get a lot more drag. Right? Mm. But the further out you go, the more predictable that orbit is, because there's no friction and it's spinning at a continuous rate. And it really, once object in motion in space,
remains
no friction,
in motion.
Stays moving.
Good old Newton.
So it becomes fairly predictable.
Yeah, no, that makes sense.
Predictable.
And there's a lot of this stuff up there from what I understand.
Yep. And they classify them as which ones are dangerous, I believe, and which ones aren't. And again, it depends on the orbit. You can see pictures if you look it up online, which orbits have the most debris. And it's astounding what those pictures look like. Now, like you said, though, you have to consider how much space is up there. It's massive. So, yeah, it doesn't happen every day, but the more that we do this, the more it will happen every day. And there's a company called Astroscale that just got, I believe, a Series E of 109 million to actually extract space debris. that's defunct and cannot be recovered. And by space debris in this case, we're talking about satellites that maybe are no longer working, and they can't. The way to typically do it is if you command it, you can tell it to burn to a lower orbit so that it will degrade into the atmosphere and burn up. Most of those will burn up in the atmosphere. They're not large enough to see some of those fall down. And then sometimes if they don't burn up in the atmosphere, they can decommission them by dropping them into the ocean. And they can time that based on when they commit their burns to change their orbit. So yeah, well, I think that's a great starting point. And I think that's what Astroscale is sort of proposing. One of the tests they're doing is with releasing a satellite-like thing that has not a docking plate, but like a plate that they can take another satellite, get to it, attach to it, and then drag it down and deorbit it.
I mean, maybe the rule should be if you put something up, you have to say how you're going to get it down eventually.
Yep, I think that's their business model. I don't know it fully well, but those are people I also know, so we could get a full discussion on that if we want to. But it's, I guess, like cleaning up the oceans too, because everybody needs the ocean, and if you've got big enough debris in the ocean, it's going to prevent ships from doing what they're supposed to do. You also have the issues with animal life in the oceans, but we don't have that in space that we know of yet.
What about tardigrades?
Tardigrades and aliens, right?
Yeah.
We need to keep space clean so the aliens can come.
Sure, yeah. That's our doorstop. That's our welcome mat.
Right.
But why isn't there, I know it's expensive to get things into space. Why isn't there a debris or a Sanford and Son in space that just goes up there and collects stuff and resells it?
That's a good question. Because it's a hard problem. Just generally operating in space is difficult. And now what you're talking about is how do you capture things that are speeding around the Earth at potentially thousands of miles an hour and grab them, hang on to them, and then deorbit them? Because you're not going to do that for every single, golf ball size piece of material. You're not going to grab it and then deorbit. You need to grab 1,000 of those or maybe 50 of them to make it worthwhile. So now you're talking about, having propulsion technology on the spacecraft, some form of semi-accurate netting system, which sounds difficult.
Or it could play Pong, just ricochet stuff off and towards the moon or something.
Well, that would be nice, but I wish we could. I'm not sure and this is where the astrophysics would come into play. You'd have to know a lot about how this all plays out
No, that's engineer. In theory, it's all Newton's laws. That'll all work. But how do you build a machine? And it'd have to be autonomous to do all that.
Well, yeah, it'll work. I'm sure we could do it. But the accuracy at which we have to have to do something like that is the problem. It's difficult. Like how accurate will we be able to track an object, line up something else? It's kind of like missile testing on Earth, right?
Yeah.
Hitting a missile with another missile. It's really hard. And they failed many, many, many times. I think they've gotten much better. I don't know what the accuracy rate is now, but now imagine that in space, it's probably just as difficult, if not harder. I don't know. Mm-hmm. It's a good question.
Yeah, the last thing you want to do is send up your cleanup satellite only to have it break into 10,000 pieces.
Right. And imagine you'd probably have to match velocity with something to really grab it.
That would make sense. Yeah.
Because if you let's just say for simple sake, you stuck a net out and then you tried to grab something that was going 1,000 miles an hour faster than you, it would definitely cause some kinetic reaction, right? Now your satellite.
The netting would be disposable at best.
And let's say the netting could support it, but now the spacecraft is going to spin, right? So now you have to prevent that from happening, which sounds really difficult. And to me, the only way to do it is to be moving alongside it and then to somehow grab it. So now you need to move up and down in orbits and adjust your speed, which to me sounds really difficult because now you're going to need a lot of propulsion capability, which usually means some form of fuel. Yeah,
because you're not going to do that with just solar.
Right.
And I know they don't like putting nuclear power in satellites anymore.
Right. Because you need to move around in space, and that's the problem. I think what makes it difficult is the fact that you have to move around.
So why then didn't this Russian mission instead hire these guys to come and pull it out of space for them? Why did they just shoot it and blow it up?
Well, because the technology isn't, it's being tested right now. This is the first time something like this is being tested. Plus, I think it's a posturing. Even if they could grab it and deorbit it, I don't think it had anything at all to do with a desire to destroy that satellite. I think it had in my opinion, that the whole main purpose of it was to show that, hey, China, US, India, we can do this too. So anytime we want, we can destroy one of your satellites, whether it be a spy satellite or not. Warfare has extended into space. It's kind of like saying, look, we have a missile that can reach the continental United States. That would be a warning shot. Now, they're not going to do that, obviously, because that's different than blowing up their own satellite in space. But it's akin to that. It's saying, we can do this to you as well. We can reach space.
I want you to expand on that a little bit. I'm not saying you're wrong, because I really have no opinion on it. It seems totally consistent with the data and plausible and all that, but I also don't want to jump to that unless, like, I trust the guy from the State Department who says it's true. You know what I mean?
Yeah, that's what I said. It's just my gut says that is likely what it is. And I don't know that anybody from the State Department would ever say that to inflame tensions. But
so is there an official story then? What's the...
Let's see. I'm looking at it right now.
Take it out.
Moscow's Ministry of Defense said in a statement that it had successfully conducted a test.
There you go.
That's all the quotes. Targeting a now defunct Russian satellite that had been in orbit since 1982.
A test of our limits.
But they don't really say anything other than that the U.S. is hypocrites for condemning it because we did it too. At a briefing Monday, State Department spokesman Ned Price told reporters that, quote, the Russian Federation recklessly conducted a destructive satellite test. He said had generated more than 1,500 pieces of trackable orbital debris. Russia's dangerous and irresponsible behavior jeopardizes the long-term sustainability of outer space and clearly demonstrates that Russia's claims of opposing the weaponization of space are disingenuous and hypocritical. See, the important thing to note here is that the test that we did was done at a lower orbit where the parts will likely get pulled in and burn up.
That's the debate for me, yeah. Is this... The way I heard it compared was it was apples to oranges to what we did. What we did, it was going, as you said, into a declining orbit and was going to be basically harmless. And this was portrayed to me as something not as benign.
Yes, I believe this was at a higher orbit. And it's hard to get all those little details.
So if they just wanted to let us know they could blow something up, why did they also have to make a mess at the same time? Couldn't there have been something else they shot?
What else is in space that you could shoot and hit with a missile that isn't going to cause debris, right? Even just blowing up a missile in space causes debris. But you might as well hit something if you're going to blow up a missile, because that's the hard part. You know, sending a missile into space probably isn't hard. Russia has sent lots of rockets into space.
Since the 60s.
Targeting it at such precision is a harder problem.
Yes, that makes sense.
There was a Chinese test in 2007 that sparked the same outcry. I remember that one.
Yeah, I remember that.
And then in 2008 by the U.S. and India at significantly lower altitudes, though, which makes a big difference.
So this one, there's like an interesting game theory angle to this on me, because we can all shoot down each other's satellites. The minute you shoot ours down, we're shooting all of yours down, right? Just tit for tat.
But
that's how it goes.
That's the same nuclear argument, right? It's, what is it called? Mutually assured destruction.
Except there's no destruction in this case. Well, there's space debris.
Well, there is destruction,
like,
though.
Citizens live on. The nuclear threat is very different.
It is, but I don't think everybody understands how integral satellites are to their day-to-day lives now.
True.
So if you were to destroy all the GPS satellites, that would be a pretty devastating blow. So much stuff operates on GPS. If you were to destroy all the Sirius FM satellites, I mean, my gosh, people might just go crazy to not have their Howard Stern.
Very true.
I jest on that one, but there are a lot of satellites that do imagery, and that data is fed into calculations that are used by companies to make decisions, farming.
Fighting forest fires,
Fighting forest fires, hurricanes, etc. I mean, it would be pretty devastating. Now, there's no real benefit for another country to shoot down the GPS satellites, because almost every country uses the free GPS satellites that mostly the U.S. has funded. If I'm not mistaken, other countries are putting up their own GPS satellites as a backup, but I don't think that would be the target of any type of malicious, warfare. Let me quote this real quick. Russia's defense ministry said in its statement Tuesday that it had been forced to boost its defense capabilities in response to weapons tests by the U.S. and Washington's decision to establish a space force in 2020. So basically, Moscow is saying, hey, look, we can do this too. We had to do it because you did it. And it said Moscow had been calling for an agreement on space arms regulations for years and urged Washington to bring its concerns to the negotiating table. So it really sounds to me, based on what I'm reading, that Russia wants to bring this to the table, this discussion to the table. They are forcing it now.
Look, I'm no traitor, but I'm red, white, and blue. But that sounded reasonable the way you read it.
Yeah.
That they wanted a discussion we didn't discuss, so they said, "Patoo."
Yep.
And now maybe we discuss.
And maybe they had, I don't know why they didn't make a decision. Well, the reason they probably didn't make a decision to use a lower Earth orbit satellite, something much lower, maybe they don't have one. And they can only shoot down their satellites.
Yeah, there's an interesting question there, but I feel like that's a weird, just pedantic dead end.
Why is that?
Because, I felt at first, okay, why didn't they shoot down one that's more apples to ours, less likely to cause space debris? But there could be some explanation, like you said. This was the only best candidate to shoot it down. If you ask some American, Orbital, I don't know who the right industry is, but the right people in equivalent other countries, would you have picked the same satellite they did if you had all the information they had? Maybe the answer is yes.
More than likely.
I don't think...
More.
Yeah, so...
Look, Russia has cosmonauts, astronauts, the Russian version of an astronaut.
Yep, that also had to shelter because of this.
Yeah, exactly. I don't think Russia wanted to cause a lot of harm, but I don't think they felt like they had a choice. It doesn't make it a good decision, obviously.
Right.
But here we are, and I think that this will probably jumpstart due to this crisis, really. That's what it takes quite often. Negotiations and discussions between China, U.S., Russia, and India, and those are really the big four in terms of space.
Yeah, I feel like that has to happen. I mean, these are, like you said, if it came to it and we started shooting down satellites, somebody would die, right? Just as a secondary effect. I was going to say no one dies. All you did was cause trillions of dollars in damages and set back progress in a lot of ways, but the supply chain disruption, people would die from that if it became aggressive.
Yeah, there would be collateral effects. Think about it from this perspective. What's the most valuable thing on Earth today? It's not oil anymore, right?
So I don't think you're going to say data.
I am. It's data.
Oh, okay.
It's
data.
It's the most valuable thing. And what is the biggest moneymaker from space is data. That data gets disseminated across the globe and used for many, many different things. People see it every day in news articles, but it is used a lot. And that data is extremely valuable. So if you're just talking about pure numbers, maybe it's not a life, but it would decimate businesses and force industries to adapt and change and cause probably supply chain issues. Like if you took out the GPS satellites, you'd probably have to have some other backup for the transcontinental ships. I mean, the list would go on and on.
Well, all right, let's compare it to ground computing. I mean, there are places where if we went to war, you might say, take out this data center in China or whatever, but no one would take out Amazon Web Services because every nation is using it in some capacity. It's this sort of shared resource. Could the same thing happen in space where I don't want to shoot it down because I'm using it too?
Well, that's what I said about GPS. I don't see that being a big threat because it is a shared resource. By the way, I would argue that China's probably building or has built the alternative to AWS because they recognize that very problem, right?
Sure. I mean, there ought to be a competition on their soil. I would think that's just healthy.
Yeah, but healthy, but also strategic in terms of the long-term success of the country, right? They don't want to be dependent upon the U.S.
because we could cut them off if we chose to.
Right.
Yeah.
China's very much like that. So back to the initial question, I think the answer obviously is yes, there should be negotiations and there should be a banning of anti-satellite tests. And it sounds like that's what Russia really was aiming for. And likely this will kickstart that.
Well, that sounds fine to me, despite the little dramatic antics, I guess.
I think that what's worth exploring is the magnitude of the problem and what the solutions look like, or what's the vision for the solutions, and we can get someone on to discuss that.
That would be very interesting, yeah. I've heard even this telltale that if enough space debris comes about, that there's this critical mass that could leave space unusable for a time. I'd like to know if that's real or alarmism.
It's a good question. I suspect it's real, and it really just depends on, it probably has something to do with the orbits you have to move through to get your satellite to where it needs to be. There's particular orbits that people prefer for particular things, and they can design those orbits in a certain way. So there's groups of satellites that are in one particular orbit, and those tend to be preferred by certain companies. So I imagine there's a cluster in a particular area, not area, but orbit, and that if we had an issue in that orbit, it would render it very useless.
That makes sense, yeah.
That particular orbit. So it might be off the table in terms of launching satellites into the ideal orbit for imagery collection, or for studying the North Pole, studying the South Pole. So you can do an elliptical orbit that spends a lot of time over the North Pole. But what if that's filled with debris? And so now you have, this particular issue.
Yeah.
That's my guess. I wish, even though I own a satellite communications company.
None of yours have blown up yet.
There's so many problems. Yeah, well, it's just that there's so many problems in the chain of what we do that it's hard to know how to authoritatively talk about each one of them, if that makes sense.
I think so.
It's kind of like in computer science, trying to learn every language. Yeah, you can understand the general concepts of how coding works, but to go and learn each language, it's just impossible. You have to pick your top few languages and what you're really good at in the domain and stick with it to get things done.
For sure.
If I was to go and try to learn everything there is about space debris, my other strong suit would suffer. Systems architecture, moving data, communicating with the satellites. I've been asked about space debris multiple times, and my answer is generally, when there's a crisis, something will change. And it looks like this is one of the crises. I'm on record saying that on a podcast for satellite communications. This is it. This is what's happening.
Yeah. They had to shelter in the ISS. That sounds a bit like a crisis.
Yeah. And is basically a particle storm, right? Little pieces of material floating everywhere.